to start with, I was explaining to you guys about how CNNs will help. CNNs, why CNNs are important for, especially in learning with image data. The first thing being the reduction of parameters due to weight sharing, and translational invariance and hierarchical representations um, that are being formulated. Um, So we worked with the CIFAR-10 dataset today, which contains uh, 50,000 images, 50,000 RGB images belonging to 10 classes of size 32 cross 32. So we downloaded the dataset and from Kaggle, and we made a custom dataset. We made a custom dataset using this code here. So when making any custom dataset, it is imperative that we define this length parameter and the get item for a self comma idx. Uh, uh, so the length parameter returns the number of images in the dataset that we want to have, and the get item returns each data point, returns the data point which we need. Um, in our case, each data, the x and y, the x is the input to the network, and the y being the target for a classification prediction that is returned when using this get item. So for each index, so we also discussed about how to do transformations on images by using this transforms.compose call from torch vision, and we normalize this. Normalize our images with the ImageNet standard deviation and the mean. Next, so we visualize the images here. This is the images. These are the images without normalization here, and these are the images with normalization. All right. Then we talked about splitting our dataset into train and validation splits using this random split function from torch.utils.data again. Um, so we split the data into with a 80% fraction. Then we discussed about data loaders. Um, Data loaders essentially do the batching for us and simplifies our code, simplifies our training loop. So yeah, so here we can see that using the batches of 64, we have 64 32 cross 32 RGB images from our dataset, which are being loaded into the memory. All right, and we have 64 labels here for labels as well. So next we defined our model, and we use this equation here, the classic convolution output equation, to determine the dimensions required for the flattened linear layer. So we hand calculated all these values. All right. Next, we did a sanity check on our model using random dummy data. So next, we go to a training loop. And to bring some novelty into our training loop, we decided that we are going to re-implement cross entropy loss. So we using our own custom class. So we defined a class cross entropy, and we defined something called the dunder call method. So this method will do the computations when an object of this cross entropy is created and they're called. Uh, so we can refer to the torch cross entropy loss to get the equation for the cross entropy loss, and we have reproduced that here uh, using these in these lines of code. Uh, right, we can see that I put some dummy data on the loss to see if it's working, because it was returning not a number earlier. So we can see that the loss is returning some actual values here. So let's then we made our training loop, which has 4 stages. Uh, Essentially, we load the images using the data loader, do a forward pass to the model, calculate the loss, and then we do the backward pass. So that essentially is uh, the is what all training loops will contain. Uh, right. So now we just have to We'll reinitialize the model and we can run the code. Mm, are we printing something? Um, for some reason, the yeah, that's essentially that's what we did in this class. I also talked a bit about batch norm. Batch norm essentially normalizes the activations of our neural network, each layer of the neural network into a distribution with a learnable mean and standard deviation. This is found. Batch normalization is usually used because it gives better performance and better accuracy, as well as it's to give some regularization term to the regularization to the neural network as well. All right. I'm not really sure why. Why this is not working. Let me just. Uh, some outputs range white size command targets my bad size. Right. I think might have been because could be long tensor. Okay. I pass some dummy input to the custom loss to see if it's returning any not a number, like other than not a number value. Let's see if it turns now. Mhm. That is. I'm just trying out if the dimension not being there. Like when we passed 10,1 tensor into custom loss, it worked. So I'm thinking of not having a dimension, having a dimension in one was the problem. Seems to be not. Just- If you guys can see anything amiss, then feel free. Um, So working on we're passing dummy data into it, but mm, uh, yes, I think I'm over shooting the time a bit. So let's. I'll stop presenting now and I'll share the quiz link. You guys can refer to the lab sheet which will be shared. Uh, that will definitely have corrected code which will run properly. I'm not sure like what exactly went wrong here. It's running for the dummy code, dummy when dummy data is passed into it. We can sort this out in the next lab. I'll start from here as well from the next lab so that we can get some closure on the problem.